Hello everyone, myself Tulsi Pawar, Assistant Professor in Physics, SPC Government College अजमेर। आज हम MSc फिजिक्स फाइनल के सॉलिड स्टेट फिजिक्स के चैप्टर सुपर कंडक्टिविटी के अंतर्गत परसिस्टेंट करंट और इफेक्ट ऑफ मैग्नेटिक फील्ड के बारे में पढ़ेंगे। सबसे पहले देखते हैं कि सुपर कंडक्टिविटी क्या है। The electrical resistivity of many metals and alloys drops suddenly to zero when their specimens are cooled to a sufficiently low temperature, often a temperature in the liquid helium range. This phenomenon was first discovered by Keonis in 1911 in mercury. The resistivity of mercury vanished completely below 4.2 degree Kelvin. The transition from normal conductivity occurring over a very narrow range of temperature of the order of 0.05 degree Kelvin. See in the figure, superconductivity refers to this phenomena and the superconductors are the specimens under this condition. So, superconductors are the materials which possess much more than the infinite conductivity. It means perfect electrical conduction under special conditions. Besides this, there are certain other remarkable properties too. Now we first study about the experimental fact regarding superconductivity and then discuss their theoretical explanation. It may be remarked that no satisfactory theory of superconductivity could be developed immediately after its experimental discovery, and the real progress in its understanding come out of experimental investigations only. In this view, the consideration of the experimental situation assumes a little more importance in this chapter. So, first we study about the experimental facts related to superconductivity. So, first topic is persistent current. If a superconductor has the form of a ring, a current can be induced in it by electromagnetic induction. We have simply to cool the ring in a magnetic field from a temperature above the critical temperature Tc to below Tc and then to remove the field. Now it has been observed that the current continued to persist with unminimized strength for days. In a typical experiment using a coil of 700 meter of lead were wound non-conductivity, it was not possible to detect any decrease of the current even in a time period of 12 hours. In another experiment, a lead ring could carry an induced current of several hundred ampere for over a year without any change. Such currents are called the persistent currents and be quite expected of superconductors. Attempts have been made to use these current in relation with the decay formula I is equal to I0 e की power minus RL upon L to place an upper limit on the value of R. Accordingly, the resistivity of superconducting lead is certainly less than 10 to the power minus 20 ohm centimeter. Now we study about the effect of magnetic field regarding superconductivity. Application of a sufficiently strong magnetic field to superconductors causes the destruction of their superconductivity. It means the restoration of their normal conducting state. The critical value of the magnetic field for the destruction of the superconductivity is denoted by Hc and is functionally related to temperature. The relation is shown in figure for several materials. For a number of superconducting elements and can be represented approximately by the formula Sc is equal to H0 bracket 1 minus T upon Tc. Here H0 is the critical field at 0 degree Kelvin, has a specific value for each material. Note that the lower the temperature, the higher the value of Tc, and the highest critical temperature occurs when there is no magnetic field. It means T is equal to Tc where Sc is equal to 0. Realize that this figure may be viewed as a phase diagram. The lower left region of the figure representing the superconducting state and the upper right region the normal conducting state. it must be added that the original observation on the destruction was made by K onus by the passage of an electric current down a superconducting wire. He found that the superconductivity is destroyed when the current exceeds beyond a certain critical value. But since current can also create magnetic field, the two phenomena according to Silsby are related. Silsby suggested that the important factor in causing the destruction of superconductivity was the magnetic field associated with the current rather than the value of the current itself. So the field effect is field controlled.